Welcome back to my Advent of Code series. Today we're gonna tackle day 5. And let's jump right into it. Supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will arrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, for example. So we have 3 stacks and there are items in them, and we have instructions. Yeah. Stack 1 contains 2 crates. Crate Z is on the bottom. Crate N is on top. And so on. Yes. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. Yeah, in the first step, move 1 from 2 to 1. So D is gonna switch from 2 to 1, and we get this. In the second step, 3 crates are moved from stack 1 to stack 3. So all of the things, D and Z, will be moved to stack 3, but they're gonna be reversed, right? Because it's a stack. Crates are moved one at a time, so the first crate to be moved ends up below the second and third crates. Then both crates are moved from stack 2 to stack 1. Finally, one crate is moved from stack 1 to stack 2. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, Z in stack 3. So you should combine these together and give the elves the message CMZ. After the rearrangement procedure completes, what crate ends up on top of each stack? So this sounds straightforward. We just need to simulate all the whole procedure, and we will have our answer. Holy crap, that's a lot of instructions. Okay. Let's create our file, day 5. We have to register here. As well as usual, I'm gonna create a static variable called the input that contains a string slice of our input, and we will create a function called parse input. So what we need to return is actually a tuple of things. First of all, we have the state of the stacks, which I think we're gonna represent it using a list of stacks, and each list contains a list of chars. Something like that. And then the second part, we're gonna parse all the instructions, the rearrangement instructions. Let me create the struct for this. Let's call this instruction. We have n, the number of items to be moved, and then we have from, which is a index, and to, which is also an index. These indices are the indices of our first vector, and we will return a vec of instructions. Okay, and how do we do that? We need to first find this double new line here. Let me change this to line feed only. So we need to detect this double new line. Tokens equals import. Well, it's not really tokens, is it? Parts. Rust analyzer? Oh, there's no const. What am I doing? I'm still in JavaScript mode. Let parse equals import split. Split, we're looking for the double new line. This will give us an iterator. And we can say state import equals parts next. And we have instructions input, which would be the next. And this could be option. Maybe let's also return an option here. Let's state import some instructions input equals state import and instructions input. Do something. Otherwise we'll return none. Hold on, what's wrong here? Oh, if let. Next, we are, let us first parse the instructions. I think this is easier. Let's implement from string trait for instruction. Error would be a tuple. And here, so this always looks like this. So let's first split the input. And we're splitting at this with the space character. Let mut tokens equals this. And then we just need to say n equals tokens. N would be the token on the index 1. Yeah, n is 0 based. So to get the second token, we need to pass in 1, and 1. And from would be tokens. Once I say n1, the iterator will move to, will consume these two tokens. And the next token I'm looking at is at the index 1 again. And 2 is also index 1. And we're gonna check the same logic. If all the three variables are of variant sum, then we'll do something. Otherwise, we will return none. And here what we do is just return, or let's put this in an else block so we don't have to write return. And here we just get instruction. Oh, yeah, the instruction needs to be wrapped in OK. Oops, we have to return error variant, of course. Here we go. And we just take n from n2. Actually, we can't, because n from n2 are string slices. We need to parse them. Oh god, okay, I need to map it because it's an option. And then I can say n parse into a usize. Turn it into an option. And then we use n to then. This should do it. And for the other variables as well. Now n is a usize, which means we can plug it into our instructions struct. And that's it. So for instructions input, we can say instructions input split, or actually use lines, and then map each line. We're gonna pass the line as instruction, turn into an option, and we just ignore all the lines that are invalid. And we can return, okay, for the first part we need to do something, but for the second part we can already write instructions in it, and else we will return none. Oh yeah, I forgot some. Oh, I need to collect it into a vec, of course. Wonderful. And now we need to pass the state input, which is a little bit more complicated. I think I'm gonna get the last line first. So we get the number of stacks. Let stack count equals state input dot lines last. And this is an option. We have to map it. So we split. We can split a white space, right? The iterator returned will return string slices that are subslices of the original string slice, separated by any amount of white space. Any amount. Yeah, that's exactly what we want. Split white space. And then we will count the number of tokens. This will give us an option of usize. Sure, we can work with options. Let me also create a mutable variable, which is of type vec_char. Actually, maybe it's a good idea to get the indices where the numbers are located at. And once we get the indices, we can directly get the characters. Right? Yeah, let's do it this way. So instead of only getting the stack count, we are instead gonna get the characters of the last line. We enumerate them, so we get the indices as well. And we filter map. So each item in the iterator will be an index and a string slice, or and a character. And now we just need to check if c.is white space. Then we'll return none. Otherwise, we'll return some with the index in it. So this will give us an iterator with the indices. Let's call this stack indices. And then we will collect it into a vec. Unused return value of collect that must be used. Oh, I have to return this, of course, no semicolon. Now stack indices is a vector of usize wrapped inside an option. Now we just need to create our stacks, which we will do by looking at stack indices and get to the inner value of the option. And then we will just stack indices. So each index represents one stack. So we map this. Oh, we iterate over it and use copied because we're only dealing with integers. So it's fine. And we map it. We have an index. And for each index, we will create a new vector. And it's gonna be a vector of chars. So it's gonna be something like that. And we have to collect it into a vector. Okay, now stacks is a wait, what? A vector of chars? No, that's wrong. Yeah, this is gonna be a vector of char. Yeah, this is our stack already. Right, and we collect it. Okay, that should do it, and we will return stacks map stacks, and then the tuple we get here, stacks. So stacks can be none if our stack indices is none, and that can only happen if state input.lines does not have a last line, which is unlikely. Yeah, okay, that makes sense. So we just need to populate our stack, and we can do that by looking at the state input lines, ignoring the last line. We already have the index where the state is located, the stack is located. And we just, actually we should read from bottom to top, right? So a vec supports removing the last item and appending another item. So this means the last index of our vec is on the top. The item at the bottom of the stack would be index 0 inside our vec. So we need to get all the lines of our state input, ignore the last line, reverse the lines, and then read from the index, something like that. Okay, let's do that. We have our state input. We get the lines. Damn, how do I ignore the last line? I don't think I can. Okay, you know what? Let's collect everything into a vec first. Because to reverse it, we need to allocate all the lines anyway inside an array. And let's make it mutable. And then we say lines. First, we get rid of the last line. So let's pop. Pop will remove the last element. And then we will reverse. I don't think the lines iterator supports reversing. Does it? It does. Wait. Is this a double-ended iterator? Really? It is a double-ended iterator. Oh yeah, I guess you can implement it in such a way that it reads, it gets the lines from the end of the string slice. That makes perfect sense. Okay. Then this is kind of easy. We get the state input, get the lines, reverse it already. And then we skip the first line, aka the last line. Yeah, okay. And then we will map it. For each line, we will get the characters and get the ith character using the index I. This will return an option of a character. So maybe let's use filter map. And now we need to filter on the character, and we can say character is not a white space. And what will it give me? So this is now an iterator over characters, over all the non-white space characters. And we just need to collect this into a vec. And we have a vec-char. That should do it. I think I'm gonna split this filter map into a filter and a map because I think it reads easier. So we filter. So if it is a white space, we filter on all the characters that are not white spaces. Yes, and then we map. We map the character away, so in the end we just need the index. And let's derive debug on our struct. And we can test our function already. Let's say stacks and instructions. Or shall I call it? Yeah, let's call it stacks instructions equals parse input. And then we would debug print. Yeah, both. Or first stacks and then instructions. Let's just unwrap. Okay, that looks good. So for the stacks, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 items, which is good. And let's compare it with this. BQC RQWZ. Yeah, looks good. We would need declare stacks as mutable. Instructions can be immutable. And now we just need to, follow the instructions, so to say. You know what? I'm gonna create a new struct for our stacks. Let's call it stacks. It will only contain a vec-char. Derive debug on that. And instead of this, we just return stacks. And the reason why I'm doing this is I want to implement some methods on stacks. And for one, we want to have a method that will do the instruction for us. Let's just call it do instruction. I can't come up with a better name. It will take a mutable self and also an instruction. Now stacks is of type stacks. And what it will do is do something n times. So we create a range from 0 to n. And we will move the item from one stack to another. On any error, do we just panic? Let's just panic. I don't have time for real error handling. Right? Right? Okay, fine. Let's handle the error. Okay, we have to return a result of empty tuple or an error. I don't know, just some error, I guess. Instruction error. Okay, let me define an enum for instruction error. Let's make this very clear what can happen. Stack does not exist can happen. So we first need to get mut index would be instructions.from, and of course from can be invalid, right? So get mut will return a none, and we will turn this into an error. Can we do this somehow? Oh yeah, we just use okay, or if it's not okay, we will return instruction error stack does not exist, and we will use the question mark to propagate the error. So let from stack, or we can just use from, and now from is immutable of vec. What is wrong here? Oh yeah, if everything goes correctly, we will return an okay variant. So from is now a mutable vector. Actually, we do not need the vector per se. We can just say, well, we got a mutable reference to the vector, and then we have to pop it. And by popping it, we will get an item, right? Item is an option of character of a char, and of course it could be that the item is none. Then this would also throw an error. Let's add an error enum variant stack empty. So we will also use okay, or, and if it is none, we will map it into stack empty and propagate the error. So item is now an item, a character, and we will push it onto another stack. So self.0.get mut instruction.to. We will do the same and wrap it, and if it doesn't work, we will throw an error. We will propagate the error, stack does not exist, and we will push the item into that. And push should always work, unless memory is full, in which case everything panics and we are gonna cry anyway, so we can't do anything about that. Alright, and now all we need to do is, for each instruction in instructions.iter, we just call do instruction on the stack with the borrow of instruction, right? And this will, of course, give me a result, which I will... Oh, that doesn't work. Instruction error doesn't implement debug. Okay, yo, let's derive debug. And this can be the result type of this function, of our test function, and we can propagate it. And in the end, we will have to return the OK variant. Let's add another method to stacks, because in the end we want to read what's on top of the stack, right? Let's call this read top. We will borrow self immutably, and as a result we will return a string. All we need to do is iterate over all the stacks and get the last item of each stack. So self0.iter map, we have a stack and we get the last item. Of course, a stack could be empty, in which case we will just ignore it, I think. So I'm using filter stack, and now we will get an iterator of characters, which we can collect into a string. And that's it. And let's just print out what we get. Read top. It failed. Wait, what failed? Stack empty? Wait, what? What? Stack empty? What do we do? Okay, I have no idea what's wrong. But let's just take this test input and see if it works with our algorithm here. Stack does not exist. Oh, right. I see what's wrong, because yeah, we're numbering the stacks. This is not 0 based indexing, this is 1 based indexing. Okay, we're assuming that the stacks are numbered 1, 2, 3, like in an ascending order and only with increment of 1, right? From left to right. Let's assume that. Otherwise we need to like map the name of the stack to the actual stack. Then we should be fine when if we just decrement everything by 1. We should be fine, right? CMZ, that is correct. And now our real input. Let's try. Okay, something. Let's see if this is correct. Yay! Now to part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writings on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001! The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. What? Move multiple crates at once? Again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to stack 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order. Ah, I see. Let's write a new function for that. Let's call it do instruction with multiple cranes. And we have to take a mutable self and a reference to instruction, and we will also return a result as before. And this time we just need to this time as before, we need to get the stack or map it to stack does not exist, and then we need to take the 3 last items somehow. We could use splice. Oh, no, we cannot use splice. We could use... I was looking through the methods of vec. I mean, for sure, we can just say... we write a for loop and we take the end of the stack, the end item of the stack, n times, push them into a temporary vec, which we then reverse and then add the temporary stack to our target stack, right? That would be possible. But now I see that there is a function called split off. It splits the collection into 2 at a given index, returns a newly allocated vector containing the elements in the range at to length. After the call, the original vector will be left containing the elements 0 to at, with its previous capacity unchanged. So we can split off, and our add would be, okay, we need the length of the vector, So we have to bind it. Let's call it stack. And we have to split off stack. And we have to get the length of stack minus 1, 2, 3, right? 3, I think this should be correct. And let's call this items, which is a vector of characters. And we would need to get the target stack. And append, it takes a mutable reference to items. We need to declare this as mut. And finally return OK. Wait, stack does not need to be mutable? Really? Split off is mutable. Needs a mutable stack. Oh, because, yeah, what we return here is already a mutable reference. So this is already a mutable reference. So this does not need to be declared as mutable. That's right. Okay, that should be it. Let's do that. Copy the code for part 1. And instead of do instructions, we will do instruction with multiple cranes. Panicked. Attempt to subtract with overflow. Okay, I see. Why did I say -3? No, we need to minus n, of course, instructions.n. Why did I say 3? Where did the 3 come from? Okay, this should now be correct. Here we go. Yay, I got this gold star.